Hello everyone, this is Ms. Page. In this lesson, we are beginning our second unit of study. This unit focuses on what we refer to as rational expressions. Rational expressions are basically algebraic fractions. So their numerators and denominators involve polynomials. And the rules that we use to operate with rational expressions, such as addition, subtraction, multiplication, division, and also simplifying, are the same rules that we use to work with our numeric fractions. So when we go to reduce a rational expression, that means that we need to reduce out common factors. So to reduce a rational expression, we will need to use our factoring skills. Some of our higher degree polynomials that we have learned how to factor are shown here. So we have, for example, a higher degree binomial, x to the fourth minus 81. And that is a difference of two squares, which we know will factor into conjugate factors, here shown here. But you may recall that in addition to that, first factoring into binomials, that we have to examine the subtraction factor to see if it is also a difference of two squares. And here we can see it is x squared minus 9 factors into x minus 3 and x plus 3, whereas x squared plus 9 would be a prime binomial factor, and so it remains the same. We also learned how to factor some polynomials that have four terms, and the method we use here, if you recall, is called grouping. First, we would want to look to see if there's a GCF for all four terms. Here that GCF is 1, so we move on to the procedure where we look at pairs of factors and their common factor or greatest common factor. And using standard form, unless you have a really good reason to do otherwise, is probably best, and group the first two and the last two. So here we see the first two have a GCF of x cubed, and that would give us that product. And the second two, we would use a GCF of -8 because the first term is negative, which is the opposite sign of the other first term. And that then gives us a binomial that matches here. And then that binomial of x minus 1 becomes a common factor of each of these pairs of factors, and then it is times the factor that would remain. And we can check that by using our distributive property and seeing that if we multiply these two binomials together, that we would get the four terms that we started with. Now, in addition to this, we realize that we have another special type of binomial here that we learned is called a difference of two cubes. And there's also a sum of two cubes. And a difference and a sum of two cubes is factored based on a pattern. So here we have our x minus 1, which just stays the same, but then our difference of two cubes factors into two factors, a binomial and a trinomial, where the basis of what is being cubed for each of these terms determines those factors. And then if you recall, we used the word SOAP to help us with the order of the signs or operations. So S, remember, stands for using the same sign as the binomial we're factoring, and then O, we use the opposite sign. So if we start with a subtraction, then the opposite of that would be addition, and then AP stands for always plus or positive there in that third spot. All right. So, we already kind of talked about rational expressions. We also want to talk about the fact that a rational expression is undefined, remember, for values of the variable that make the denominator equal to 0. And we often refer to those as excluded values, meaning they're basically not part of our domain. They're not part of the set of values we can use for our variables such as x. And so one of the key things too about rational expressions, how to differentiate them from other types of expressions in mathematics, is the key presence of a variable in the denominator. Here in this first one, we see we have two variables. We have an x and we have a y. Here we have an x, here we have an x or an x cubed. So that's the key thing that identifies a rational expression. And so here, although this is written as a ratio or a fraction, the 2 in the denominator doesn't involve a variable, so that's not a rational expression. That's actually a polynomial in a ratio form. If we divide both of these terms by 2, we get 3x plus 3 halves. So it's a polynomial, actually. And the same thing here. Although there are fractional coefficients, those fractions, again, in their denominators have no variables. So this is also just a polynomial, not a rational expression. So a rational expression requires that we have a ratio of polynomials where in our denominator there is a variable. All right, so went a little fast there. This is just our process for reducing a rational expression, and I've kind of already touched on that. We're going to want to factor our numerator and denominator completely, reduce our common factors, and then at the end we will simplify our expression by making sure that if we have any products of factors, that we multiply those together so that our numerator and denominator are in standard form. All right, so here our instructions say that we are to simplify, which, given the structure of our expression as just a ratio or a fraction, we should understand does mean to reduce to lowest terms. We also have a second portion of our instructions that say state the excluded values. Now, excluded values are where our expression is undefined. So they are specifically determined by our denominator. I highly recommend that you do your excluded values first because they refer to the original denominator, not the reduced denominator, which can be different. So the first thing I would do would be to look at that denominator of 4x squared plus 8x, and I want to know for what values of x is that denominator equal to 0. So this is like solving a simple little quadratic equation. Here we have a GCF of 4x, so we factor that out, and that gives us x plus 2. And then our zero product property, we set each of those factors equal to 0. And here we divide by 4, which gives us x equals 0. Here we subtract the 2, which gives us x equals -2. Now, these are the values that x cannot be. So we also often like to say, all right, this cannot be equal to 0, not equal to 0, not. And so these would be our excluded values. Then moving on with the simplifying or reducing of this rational expression. So I would factor both my numerator and denominator completely. My numerator is 4 terms. And looking at the 4 terms, the GCF of all 4 terms is just a 1, so I move on to grouping. So my first 2 terms, they have a GCF of x squared, and that would be x minus 1. And then my second 2 terms, I want to use a GCF of -4, and that would then also be x minus 1. My denominator, I've actually already talked about its factoring here when I figured out my excluded values. And so I get GCF of 4x, and that gives me then x plus 2. Not done with my numerator yet. So again, remember that this binomial has to be the same to move to the next step in this type of factoring, that is now a common factor. So I factor out the x minus 1, and that is times the other factor that is formed by what remains, which are the GCFs of x squared and minus 4. And then I have to realize that my x squared minus 4 is a difference of 2 squares, and so it's going to factor into an x plus 2 and an x minus 2. And so now I'm looking at reducing my common factors. So I have common factor here of x plus 2, and those will reduce to 1. 4, there's no GCF that involves a common factor with 4 nor with x. So what I have here now that remains is I have an x minus 1 times an x minus 2. I would want to multiply those two together to simplify that into standard form, giving me x squared minus 3x plus 2 over 4x times 1, which of course is just 4x. So this would be my simplified expression. All right, moving on. So here's another example. And same instructions. So again, I would again start with those excluded values. So I am looking at where my denominator would be equal to 0. In fact, remember, these are values that cannot create a 0. So you can actually start with your just not equal to and then keep it all the way through, and you'll have the form of the answer that you want at the end. So here we have a little quadratic trinomial that would factor into the binomials x minus 6 and x plus 1. And each of those factors cannot be equal to 0. Here adding 6 tells us x cannot be 6. And here subtraction tells us x cannot be negative 1. So done with that part. Then looking at simplifying, I have x minus 6 over my factored form of my denominator, which once again is x minus 6 and x plus 1. So here we have between our numerator and denominator a common factor of x minus 6. Be careful. I see students often make mistakes here with forgetting or not realizing that remaining factor of x plus 1 is in the denominator. Therefore, it has to stay in the denominator. Otherwise, you don't have the same equivalent expression. So your numerator is this factor of 1. So it's very important to realize those don't just cancel out and go away. They reduce to 1. And so what you have there is 1 over 1 times x plus 1, which is x plus 1, like so. All right, and a third example. This example, we're going to introduce the topic and concept of binomials that are opposites of each other. And opposites, just like in numbers, if you have two opposite numbers like 3 over negative 3 or negative 2 over positive 2, those will reduce to negative 1. Opposite binomials do have a particular structure that you can learn to recognize. So we have ax minus b and then b minus ax. So the terms you'll notice are flip-flopped. Some people have a hard time always recognizing in that form that they've got opposites. So we'll talk about another way that we can do that too. So here I'm looking at, again, doing my excluded value. So I'm going to do that first. So again, that's where my denominator would be equal to 0. Those are my can't be equal to those x values. So x squared minus 9 is a difference of two squares. You could factor it as x minus 3x plus 3 and use your zero product property. You could also say x squared cannot be equal to 9 and then use your square root property. Do you remember with your square root property though, then you have that plus or minus over here on the square root of 9 side. So either way, you're going to get x cannot be equal to negative 3 or positive 3. All right, so now looking at the simplifying part. So we have this 6 minus 2x. So 6 minus 2x, you might look at that as having a common factor of 2. And if you do, that's fine. What you're going to get is 3 minus x. And your x squared minus 9, difference of squares, factors into x plus 3 and x minus 3. What you have to recognize, though, doing it this way, is that the 3 minus x and the x minus 3, which are flip-flopped around that subtraction sign, that's the form where we have opposites, and they will reduce to negative 1, not to 1. If you have you have another option. If you don't, if you're thinking that you're going to have a hard time recognizing when you have opposite factors, then what I recommend is, notice how 6 minus 2x is not in standard form. If I put that into its standard form, then the first term is a negative 2x, and then I have a plus 6. So in this case, because that first term is negative, what you would do then is factor out a negative GCF. So you'd factor out a negative 2. When you factor out a negative 2, you get x minus 3. And now you have x minus 3 and x minus 3, which are common factors, not opposites, and they would then reduce to 1. And here's the negative that you get when you reduce opposites, because in the previous, if you had 2 times your 3 minus x, this would reduce to -1, and then that would give you your 2 times -1, which is this -2 here. So that's what we're looking at there. 2 different options for factoring opposite binomials correctly. So now what we have is -2 times 1, which is just -2, and x plus 3 times 1, which is x plus 3, and that gives us the simplest form of our expression. All right, here is a practice problem. I encourage you to pause the video here, try this problem, and come back when you're ready to check. All right, let's take a look at the answer. So here we see our excluded values where we're using our denominator. So those 2 factors cannot be equal to 0. So x cannot be -3 and x cannot be +2. Here we have opposite factors. So this shows just recognizing the structure of opposite factors and reducing them to -1. As I said, your other option would be to look at your numerator, -x plus 2, in standard form, and then factor out -1 as your GCF. Reduce those to 1. -1 times 1 gives you -1 over x plus 3. Another practice problem. Again, pause your video here. Let's take a look at the answer now. So here we're looking at excluded values coming from this denominator, which has these 3 factors shown here in the grouping. And so the x plus 2 is a repeated factor. You only need to do that one once, which gives you the excluded value of -2. There's no reason to have to write the -2 twice. If you did that, just keep in mind it's only required once. And then we have our trinomial here, which factors into those. Now, when you get to this point, notice both x plus 2's do reduce. In this case, it's a 1-to-1 reducing. So you have a 1 there and a 1 there, and 1 times 1 gives you a numerator of 1 again, or previous one was a -1. All right. Now we are back to another example to put into our notes. So again, I'm going to start with my excluded values. So I'm looking again at where my denominator would be equal to 0, and those are the values that I cannot be equal to. And so x to the 4th minus 64, I need to recognize, is a difference of 2 squares, where x to the 4th is x squared to the 2nd power, and 64, of course, is 8 to the 2nd power. So be careful here. Remember that your 2 binomials then are going to have to start with x squared, because you have this x to the 4th. And then you have a plus 8, and you have a minus 8. And those cannot be equal to 0. So what we're looking at here then is realizing. So our x squared plus 8 cannot be 0. X squared minus 8 is not a difference of squares, so I'm going to have to use my square root property to help me with this one. The reason I didn't mention that here is because when I subtract 8, I'm going to get -8, and when I take the square root, notice I'm taking the square root of a negative number. That's imaginary. When we're doing problems of this type, we only worry about real numbers. So they could be rational or irrational, but imaginary numbers don't apply to excluded values. So when we're working with rational expressions, we only work with real numbers, rational and irrational. So this one though, when we add 8, this is going to give us 2 excluded values that will be irrational. And so we get our x's cannot be equal to, and then the square root of 8, remember, will simplify because it has a perfect square factor of 4. And this would give us a positive or a negative 2 times the square root of 2 in our simplest form, which is expected that we simplify things like that for these problems. You can write it in the plus minus format, that's fine at this point, or you can separate them, either way. All right, now we're going to look at simplifying. So we've actually already looked at our factored form for our denominator. Our numerator, notice here we have a GCF of x. Therefore, the x squared plus 8 does become a common factor that will reduce to 1. And then x times 1 is x. And our denominator is x squared minus 8 to complete the problem. And another example, a little higher degree of work factoring to be done here. Again, I'll start with my excluded values. So I'm looking to see where my denominator would be equal to 0, and those are the values I cannot be equal to. Here I have a GCF of x, and that is x plus 3. So therefore x cannot be equal to 0, and x plus 3 cannot be equal to 0. And so x cannot be equal to 0, and x cannot be equal to negative 3. Then for simplifying, so here's where we have to recognize that our numerator of x squared, or x cubed rather, plus 27 is a sum of two cubes. And a sum of two cubes, we look at the base values that are being raised to the third power. And a sum of two cubes, like a difference of two cubes that I talked about in the beginning of the lesson, factor into a binomial and trinomial factors. And we use the word SOAP to help us make sure we get our signs or operations correct. We use the x and the 3 and the same sign in our binomial, so we get x plus 3. Then we take our x and we square it. We use the opposite sign, so minus. Then we multiply the x and the 3, which gives us 3x, and then always plus or positive in that third spot. And then we take our 3 and square it, which gives us a 9. Over, we've already talked about the factor in the denominator, which is x times x plus 3. So here we end up with a common factor of x plus 3 that will reduce to 1. So what remains is our x squared minus 3x plus 9 over x to finish the problem. All right, let's move on. So here's a practice problem. Again, I encourage you to pause the video, try this problem, and then come back when you're ready to check. Let's take a look at the answer. All right, so for this denominator, we are looking at a GCF of x squared. And so there is no positive or negative 0. 0 is just 0. So that's like a double again, like we earlier saw with another problem. So you only have to write the 0 once, and then x cannot be equal to 5. Here, what you have to realize, a little bit more advanced factoring here. In your numerator, you have a GCF of x, and then that gives you x cubed minus 125, which is a difference of two cubes, where the x is being cubed and a 5 is being cubed. So we use the x and the 5 and SOAP with our signs. So that's where these factors are coming from. We have the GCF of x right here, and then we use the x and the 5 in the same sign for x minus 5. Then we take our x and square it. We use the opposite sign, which would be plus. We multiply the x and the 5 to give us 5x, always plus or positive in that third spot. And then we take the 5 and we square it, which gives us that 25. And then we can reduce the x and the x squared, so that is a 1, and the x squared becomes x. And we can reduce the x minus 5s, which both become 1. So that leaves us with that particular expression in simplest form. And another practice problem for you to give a try. All right, let's take a look at the answer. So here we're looking at a quadratic, actually not quadratic, but a quadratic form where we have a trinomial. This x to the fourth minus 26x squared plus 25. So it first factors, which isn't shown here, into, actually it is shown in this part. So x squared minus 25 and x squared minus 1. And then those are both difference of two squares, so they factor that way. Or you could have used for this excluded values part, your square root property, which should have given you the same final values, here all shown together, -5 and +5, -1 and +1. So then we have a regular old trinomial here, which factors into x minus 5 and x plus 1. All 4 of our factors from our denominator when it's factored completely. So our x minus 5 is reduced to 1, our x plus 1 is reduced to 1, and that then gives us a denominator, or numerator rather, of 1, and you should multiply, to use your distributive property to multiply the x plus 5 and the x plus 1 together, x minus 1 together, so they're in standard form, giving you that trinomial in your denominator. All right, that finishes up this lesson. I hope you have a wonderful day.